All right, here's another example. So we want to sort of kick it up a notch to 3 dimensions. So now we want to look at vectors inside R3. So up till now, our discussion has been about vectors in R2, so 2D space. Now we want to think about 3D space. And the question here is, does negative 1, 1, 1 belong to the span of these two vectors 1, 1, 1, 1, 2, 2? So can we write this thing as a linear combination of these two things? So that's what we set up here. Can we write negative 1, 1 as a linear combination alpha times the first vector plus beta times the second vector? And so as usual, this amounts to solving a system. Here is the first column of your augmented matrix. Here's the second column of your augmented matrix, just like we did in the 2 case. And then here's the augmented column, right? So if you multiply all this by alpha, multiply this by beta, add them up, set them equal to this thing, you'll get a system of equations. You'll get 3 equations and 2 unknowns. So that's what this thing is. So now you want to take this thing and put it in reduced row echelon form, basically solve the system. And you can see here that yes, we do get solutions. Alpha is negative 3. So alpha is negative 3 and beta is equal to 2. So beta is equal to 2. So the answer is yes, right? We can write negative 1, 1, 1 as a linear combination of these two vectors in the span, right? So negative 1, 1 is equal to negative 3, right? So negative 3 times the first vector plus 2 times the second vector. And if you work this out, negative 3 plus 2 is negative 1. Negative 3 plus 4 is positive 1. Negative 3 plus 4 is positive 1. So that works out. So we've just shown that this vector is in the span of these two vectors. What about this thing? What about 0, 1, 0? Does it belong to the span of these two vectors? Well, in other words, can you reach this vector using only these two directions? And if you think about R3, right, there's like a left, right, and there's also an up and down, or there's like a left, right, and up. So it takes 3 basis vectors, or like 3 fundamental directions to get to everywhere in R3. If you've only got 2 vectors, you should expect not to be able to get everywhere in R3. Just like before, when we only had 1 vector, we cannot get everywhere in R2. It takes 2 vectors to get everywhere in R2. It takes 3 vectors to get everywhere in R3. And if you've got less than 3, you can't get everywhere. So here's an example. Here's an example of a vector that's not in the span, right? It's in R3, but it's not in the span. So not every point is reachable using these 2 directions. How do we know that? Well, set up a system. First column, second column, and then the augment column, right? And then you put the thing in reduced row echelon form. You see here you get 0, 0 is equal to negative 1. That, of course, is an absurd statement. So this equation has no solution. This system of equations has no solution. So the answer is no. This thing is not in the span of these 2 vectors. And what does that show? If you find one single thing that's not in the span of the 2 vectors, that means these 2 vectors cannot possibly span all of R3. In other words, not every point in R3 is reachable using these 2 vectors. So what does the spanning set look like? It lives in R3, so like if you think about like an open box that goes in all directions forever, what's the span of these 2 things going to look like? So you've got these 2 vectors. The span of these 2 vectors is going to turn out to be a plane. So one single vector will sweep out a line. 2 non-parallel vectors will sweep out a plane. 3 non-coplanar vectors will sweep out all of R3. So just some geometry to keep track of as you're going through this, right? One vector will sweep out a line, right? So one vector forward, you can go forward or you can go backwards along that line. That's all the linear combinations. two vectors that are not parallel will sweep out a plane. If the two vectors are parallel, then that means it's really just one vector, and again, that'll sweep out a line. And then if you've got three vectors that are not coplanar, they're in fundamentally different directions. That means they will sweep out all of 3 space. Let's go ahead and look at another example of the spanning set of some vectors. Maybe now let's look at 3 vectors in R3.